Well, hello everyone, and welcome to the next episode of CyberJar live streams. My name is Catherine Edelweiss. I'm a developer advocate at Bellsoft, and I'm joined today by Rogerio Robetti, a senior software engineer and the father, I may say, of Open J Proxy, the tool that we are going to discuss today. Hello, Rogerio.
Hello. Thanks, Catherine, for having me today. It's a great pleasure to be here. I was talking to you before, and I've been following your work here at CyberJar. It's a fantastic channel, and I'm very happy to be here today.
Thank you so much for coming. It's a very exciting topic. I must admit I haven't heard about OGP before we met. So for me, it's going to be also something very new and exciting. I know that you are based in Dublin now. Currently, what's the time now in Dublin?
Now it's 5:04 p.m. The weather is lovely outside. It rains, it's windy and cold.
Yeah, sarcasm. I feel sarcasm.
There is a lot, yeah. Winter in Ireland, the best thing is if you're not in Ireland, but the city is lovely. It's full of the Christmas lights, so it's beautiful when you're out. But the weather is not. It's not as beautiful.
Oh, so Ireland is also preparing for Christmas already, right?
Oh yeah.
That's
The
cool. I
shops
love
are
it.
preparing for 2 months, right? The trees are out for the lights,
Oh
selling
yeah.
you things for 2 months already.
Well, actually, it is my dream actually to come to Ireland because I have a very tight cultural bond to the country. Although I'm not a native English speaker and I have never been to Ireland, but I wrote my thesis dedicated to the Irish mythology and literature.
Oh
So that
wow.
would be really cool for me to visit the country someday. Have you ever been to Kazakhstan?
Not yet, but I would love to. Yeah, and when you come to Ireland, please let me know.
Of
I'll
course.
give you the right tips and hopefully have a coffee or a Guinness with you.
Oh yeah, I'm sure. I think that's a must in Ireland to drink some Guinness. Exactly. All right, friends, we are about to start. So say hello in the chat. Say where you are joining us from. And if you have any questions to Rogerio or to me, feel free to post them in the chat and we will make sure to answer them to the best of our abilities. Right. So, Rogerio, are you ready?
Ready, born ready.
All right, great. So, Open J Proxy. Well, before we dig into actually exploring the tool, can you please tell us what kind of problem are we solving here, trying to solve?
Yeah, absolutely. Yeah. So the Open J Proxy is a long-standing question in my mind. It started in 2018, actually, during a migration to microservices. Right. I think many developers will relate to this. That you start a migration to microservices, you're breaking down your domain into the small microservices, and then you come to a decision on what you're going to do about the database, right? And at the time, the database would remain a single database with different schemas, right? I think it's a common approach for many companies, as we found out in one of our meetings recently in the OJP community. What it produces in the end what we call the distributed monolith, right? Really, because
Yeah.
if the database is still centralized, you're not fully microservices. I don't say it in a bad way. Sometimes it's the reality, right? And we do need to work with reality.
Of course.
So at that time, the question that arose and that I brought to the discussion board in the architectural meetings was, if we are creating microservices, right? We are creating all these microservices and they scale elastically, right? And they start, let's say, with 2 instances, they can go to 20. What happens when we reach the 20, right? And we have a connection pool in each instance of these microservices. Even if it's a small connection pool, say 10 or 20 connections, if you're dealing with 10, 20 instances, that goes to hundreds of connections. And you're hitting the database with those hundreds connections. for one microservice. If you have more microservices like we just described in a distributed monolith, that becomes even worse. At the time, it was a very, very big company. So the answer of the architects was basically like, we can put more hardware, right? Like we have the money, like we can put another Oracle rack, it will be fine. And it was no trouble there. Like the money, if you throw enough hardware, like you can always make things work. But the question remained in my mind, like, I don't think that was the solution, right? The solution would be something that allowed us to have the microservices connecting to this database, and that to use a connection pool, because we did want to use a connection pool in a way that we didn't create a what we call a connection storm, right? Because if you have all these instances opening connections without control to the database, sometimes you create what we call a connection storm, and that can cause troubles to the database, increase the pressure, and sometimes brings the database down. Because if you're in an increase of demand and you don't stop pushing pressure into the database, we're going to talk about other strategies we use. But the main thing that a connection pool can create for you is a backpressure, right? But if you're creating connection pools with the microservices, you lose that. So the main motivation for OJP was this long-standing question on how can we solve that. And in a brilliant morning of probably October or November last year, an idea came about, which was why not to externalize the connection pool into a proxy, which is not a new idea. That there are proxies already in the market, like CMAN or PG Pool, or there are options there, like the Aurora proxy from AWS. There are many proxies, but there is no proxy first that is fully open source and database agnostic. That doesn't exist, right? So that bothered me, because if you, let's say, you invest time learning a proxy, how to implement it, how to deploy it, and then you change your database, or you use two types of database, let's say Oracle and Postgres, which is a very common setup. You use Oracle for the most critical applications and Postgres for maybe internal applications, less critical. And people use Postgres for critical applications as well. I'm not saying the opposite. But I did work in a situation that was like that, Oracle for more critical and Postgres for more experimental applications. And then you need to use two different proxies, right? And that bothered me as well. So we didn't have that. We also didn't have a proxy written in Java, right? Fully written in Java. It's not something you normally see. And the idea for the OJP came about from that. So why not to create a POC of a proxy that's separated from your application? So it gives you the ability of centralizing this connection pool outside of the application. So the application can elastic expand without worry about how many connections it's opening, because who is really creating the real connections with the database is the proxy. So the proxy can maintain that number under control and create this back pressure that is desirable for the database to be protected.
I see. So you said that there are already similar solutions, and as far as I understand, the main difference of OJP from other proxies is that it's written completely in Java, right? Are
Yes,
there any other differences?
Absolutely, yeah. So that's one difference. The other difference is that it's fully open source, right? So if you get CNAM, for example, is Oracle technology. It's not open source. You need a license for that. If you get Postgres or Postgres proxies like PGPool or Proxy SQL, which is more for MySQL, they are close to the database protocol. So there was nothing that was more close to the application perspective of managing connections. So either you have a proxy that is tied to the cloud provider or to the database. We didn't have something that took the proxy problem from the perspective of the application, right? So, and what do I want to say from that? Like we have Hikari CP, for example, which is the full connection pool of Spring Boot, right? It's been loved and trusted for more than a decade now, maybe. And why not to put that proxy, that connection pool into a proxy, and use something that we Java developers already trust and have experience with to continue to coordinate our connections, but outside of our application. So another difference would be as I mentioned, I think the focus point was the freedom. What bugged me the most is that you didn't have the freedom of choice of databases, because if you chose a database, you would have to use that proxy. If you choose a cloud provider, you would have a proxy, but only in that cloud provider. That creates extra costs in the process, because if also prevents you from changing. Sometimes you could believe that maybe the best it would be to change a technology or a cloud, but because you have these constraints on technology that you learn and that's not easy to port, you end up not doing the migration, right? And I think that's a problem, like is a structural problem that I wanted to address. Wanted something that was fully free, fully open source, Apache 2.0, written in Java, because we are Java developers. Like if there is a problem, we can help to solve, right? And Java is a robust technology. It's been here for 30 years now, like has been battle tested more than most of the languages we have out there in the environments. And another big change I would say is that I think those are the core fundamental changes. Like I'm not going to go into details of functionality yet. I think we can evolve into the conversation later into that.
Yeah.
But there are other things that I believe we are doing differently, but they are at the level of like, how do we manage connections? What value do we deliver with this proxy? But in general differences, I would say that it's written in Java, is fully open source, and database agnostic. Those are the three big ones.
How do you actually use it with the application? Do we need to refactor the code somehow?
No, we don't. I prepared a small demo if
Oh,
you want
cool.
to go through it.
Yeah, sure. Let's just go ahead. Yeah.
Yeah,
Start with
I'll
the
just
demo.
present it here. So share screen. I'll share this entire screen. It's easier. So yeah. So this is our GitHub page, right? So when you come here, click the start button there. That's the first thing you need to do to support the project. So we have a very extensive documentation. We've been working quite a lot in having a rich documentation to help people on how to do things. I'll start from the front page. So to integrate OJP or to start testing it at least, it's basically 4 steps. I'll just read them out here so we can follow them later. The first thing we're going to do, we're going to run a Docker container with the OJP server. This is the architecture. Oh, apologies. It's a bit down here. This is the architecture of the OJP. So we have the proxy server sitting in the middle there with the Hikari CP pool. And we have the JDBC driver, which we implement. So OJP implements a JDBC driver that connects to our proxy. That way, so it is also the only JDBC level 3 driver is fully open source that exists in the planet at the moment. So we are the first fully open source JDBC level 3 driver, because we connect to this proxy. We use gRPC, so it's a very efficient protocol, right, to connect to the proxy, a multiplexed protocol. And then the proxy itself creates the real connections to the database, and it manages them in a more efficient way. So to integrate, let's start our Docker with the server. I just wanted to show the picture so you can visualize what we are doing, right? There is 2 parts. The first one is the server. I hope the letters are big enough here. Is it readable, Catherine?
Let's see. Can you make it a little bit bigger?
Bigger? I can, yeah. Let's just get here. Maybe this will. Is that better?
Yep.
Yeah, if you feel that it needs more, just let me know.
Of course.
Yeah, there is our OJP server running there. We do have as well a few databases running here, because I usually test with multiple databases, but the one we're going to be, well, actually we're going to be showing an H2 test, integration test, but I test a lot with Postgres. I find Postgres a very good database to test. So let's go back to our page here real quick. So the first thing it says we're going to be doing in the app itself, this is just to start the server, right? We're going to put a dependency, and then we're going to change our connection URL. You see here that this is the Postgres connection URL.
Please make it a little bit bigger.
Of course, yeah.
The page, yeah.
Good idea.
Okay. Yeah. Oh, yeah. Fabulous.
Yeah, that's better for presentation. Thanks for that. So we maintain the connection URL basically untouched. What we do, we just put a prefix, right? So the OJP underscore with the location of the server in the middle here is our pattern. So you can tell the driver that you want to connect to this OJP server. So your connection URL will just have to add this prefix, and it should work out of the box. Of course, if that would work with the full configurations, right? Which for real purposes you're not going to be doing, but for a test, you do these 3 steps and you should be good to go. Now, we do have documentation in relation to how to integrate to specific frameworks. So if you come to our documents page, Java frameworks, we have documentation for Micronaut, Quarkus, and Spring Boot. As we're going to be showing Spring Boot, I'll click Spring Boot here, and I'll be copying the code from here. I have a little shop service here. This shop service is basically an online store, right? So it has users, reviews, products, orders, order items, and it has integration tests for all of those, right?
Can you please make a little bit bigger? In the ID?
Yeah, let me just... I forgot the shortcut for IntelliJ now.
Oh, yeah, me too. And just a sec. There was a button.
Shift. No, it was something plus.
Yeah, just a sec. I'm trying to remember too. I don't remember it, to my shame.
Oh yeah, started now. Yeah, here. Is it big enough?
Oh yes, thank you so much.
Yeah, apologies. I think it's okay. Shift plus. Okay, so let's run the test, right? This is without OJP. There is just a Spring Boot app, right? Running with an integration test against an H2 database in memory. So it should pass. Okay, that's working. Now we're going to start implementing the steps we see here, right? So let's copy our dependency. This is our JDBC driver. So the OJP implementation of the JDBC driver. So it's the first thing we're going to change here. We're going to get rid of our Postgres driver, and we're going to add our OJP driver instead. So that's done there. We need to remove our local connection pool, right? Because we are delegating the connection pooling to OJP. So the OJP server will take care of connection pooling. As a Spring Boot starter comes with a Hikari by default, we're just going to exclude it, right? Simple as that. So let's just find the Spring Boot starter. Remove the plus that I added there. And save this. That part is done. And now we need to take care of our application properties, right? As we are running a test, is the application test properties we're going to be changing. So we're going to be using this prefix here. I can copy it from here because I'm running in localhost, right? If you were to be running the OJP server somewhere else, you put the IP or your DNS in the port that you started the server on. But as we are running locally here, that will be our location. We have 2 data sources here just to show the flexibility of OJP. So you can immediately use different data sources. And you can put a name to a data source. And the way in OJP to put a name to data source is just you put in brackets here, the name. And that makes it pick different configurations for different data sources. The driver class name has to change, obviously, right? Because now we are using OJP driver, not H2 anymore. That goes there. And because this example has 2 data sources, I'll have to do one more step, which is to create an OJP properties file to specify the the properties for each of these data sources. So OJP properties. And I left it prepared here in a text file, what we would be needing to use.
Mm-hmm.
So we can see here how we deal with different data sources, right? So this is let's say one of the properties for OJP. So it's the maximum pool size, minimum pool size, and connection timeout, right? So if you want to set for a different data, this is the default data source. So if you just have one data source, that's what you're going to be putting as configurations. There is more, of course, more pool configurations you can check in our documentation. These are the basic ones, right? For just for the demo. And the way to name a data source, you just put a prefix, whatever name you want. You start with that name and then continue with the same properties there. So here, this case, we have two pools, right? One that starts in 5 connections and can grow to 25, and a more, what we call it here, a high performance pool, which will start from 10 and can grow to 50 connections.
How
right?
do you actually calculate the optimal pool size for the application? Can OJP help with that, or is it just through performance testing?
The right way to calculate is through performance testing, right? So you should do an evaluation of what is your average expected production loads and what is your expected maximum production loads. And you should test for that with different configurations for the pool. That's the best way to do that. Now, in our experiences, it's common and very frequent that using less connections produces better results. And the reason for that is that if you open too many connections, the database uses its resources to switch between connections instead of actually doing database work. It's very efficient to do that. But if you can save any work that the database is doing that is not related to saving data, retrieving data, you should try to do that, right? So whatever work that the database is doing that is not database related, we should try to remove from the database so we get that extra little time for the database to actually save data, retrieve data. So the best configuration for connection pools is the one that your test shows. In general, less connections deliver better performance. It's very common that less connections deliver better performance. I need to talk about a slow query segregation strategy that we created later after our demo. Because as you reduce the number of connections in the pool, how do you prevent slow queries from taking over the pool? Let's say you have only 20 connections. What if you have 20 slow queries, and they all take place in the pool and everyone else waits for their time to execute? So let's talk about that later. For now, I think we're ready to go. Let's just go to the document.
We already have a question from the audience, but I'll ask it after the demo, right? So that
the demo is pretty much, now we're gonna run this again. It should pass all the tests, right? And we are not connecting directly to Postgres anymore. We are connecting through OJP, and OJP will connect to the Postgres database. And that's it. And to prove that, we're gonna kill OJP just because it's fun. So we like to do some Chaos Monkey tests here.
Chaos Monkey. Friends, if you haven't tested it, it's a nice tool for introducing chaos, controlled chaos into the performance testing. So to see how your application reacts to unexpected things happening.
Just kill things out of the blue and see if your application survives. I think is a good way to test things. It came from Netflix. And by the way, I always like to call it out. Like, I think we don't give credits enough to Netflix for all they have done. Many people do, but it's always good to call it out. Like, it came out of Netflix, like many other things we use and used for a long time.
Oh yes, anyway, I love it that they always try to stay on top of the technologies. They were among the first to migrate to the virtual threads and to actually give some results on that. So yeah, it's always interesting to watch them and how they
100%. Yeah.
do that. Yeah.
Yeah. It's someone to look up to for sure. That they're driving the change. Yeah. And it's very impressive. Our OJP server is dead now. Like the expectation here is that now it fails, and this test is just to prove that it was going through OJP, right? That I'm not,
Yeah.
I'm not,
And there's a question
not
related to
lying.
the demo. So how does Spring know about the OGP properties that we used?
How Spring knows?
Yeah.
Spring doesn't know. That's the magic here. So
Mm-hmm.
what OJP does, it reads from your resource folders. From your resources folder,
Mm-hmm.
or from your root folder. So if you have an OJP properties in your root folder of your project, or in the resource folder, the OJP driver will look for it and will load. It doesn't depend on Spring for anything. We do have an idea to create an auto-configurable Spring annotation to make this auto-configurable,
Mm-hmm.
but we didn't design it yet. We don't know how that would look like. OJP is not designed for Spring, so it doesn't rely on Spring tooling to do anything. So that's why it's so easy to deploy to Quarkus or Micronaut or any Java application. You
Mm-hmm.
could deploy it to any Java application and it should just work. Where it integrates with Spring is through these properties, right? At the moment
Mm-hmm.
you pass these properties to Spring and tell Spring to use the Open J Proxy driver, there is where the magic happens, because the OJP driver is a fully functional JDBC driver, JDBC type 3 driver. So from a Spring perspective, it's just working with a JDBC driver, right? We just respect the contract of the JDBC specification. And with this little detail here, we tell our driver where it should go for the server. So putting all this together, like the OJP properties, the driver, and the little change in the URL, we have all the information we need, right, to go to the proxy. And we send, obviously, the information about the connections from the client. That's a difference from some other proxies. In some other proxies, you would have to configure this in the proxy, which we found that it would be too much of a change for Java applications. We have all the configurations in the apps. So why not reuse that structure and to reduce the noise for migrating? So
Mm-hmm.
we
Yeah.
send it to the server, all the parameters that it needs to connect to the database. It's safely sent. We are very concerned about security, how that happens, and how not to expose that. I'm not going to go into full detail of that, but if you have questions about that, I can respond through chat, through LinkedIn, in our Discord community as well. And then the server will open the connection pool and will start providing virtual connections to the application. That's how we call them, because they are not real connections anymore. Our driver doesn't provide real connections, and that's how we can provide a lot more connections without the burden that would be put in the database.
Mm-hmm.
The demo was this. I'll maybe stop sharing for a second and we can go through questions.
Yeah, and there's another question. Yeah, so how transaction management works in Spring with OGP data source? The audience.
The same way it worked
Mm-hmm.
before. You don't need to change a comma, a semicolon. We also support the X8 protocol. We recently implemented X8 protocol. It's still in experimental phase in OJP. In the next version, it will have a more robust version for distributed transactions. But for normal transactions, we have extensive testing in our pipeline, and it's very robust already at the moment. So nothing changes. Like you put your at transaction annotation in your methods, everything will work as it did before with in relation to transactions.
And so OGP does all the heavy lifting when it comes to traffic surges, right? So it does it
Yeah.
automatically.
Yeah, so we implemented it in a way now recently, and maybe I'm talking too much about the next version, but what we are currently working for the next version is the high availability of OJP. So here I showed just one server, right? From version 0.30 beta, which will be the next version, we're gonna deliver the ability of deploying a cluster of OJP servers. So you're gonna be able to to point to multiple OJP servers just by listing them in that URL that we saw. And if one goes down, the remaining ones in the cluster will compensate the amount of connections that were lost. Let's say you start with 3 servers, one goes down, and it was 30 connections that you intended to have. The other 2 will open 5 each and will compensate. And once the server comes back, it will open its 10 connections back, and the other 2 will kill 5 connections gracefully. No, will not kill right away, right? We wait. When they are idle, they will be dropped, and the database will remain with the desired number of connections. There is one test, if I may share real quick, that's very interesting to. I'll just share again.
And
there is one test in our pipe.
Yeah. Okay, add to stage. Yeah. All right.
If we come here, we have, let's go to the latest actions here. And let's see. Yeah, these are all PRs. That's why they are failing. So they are not real failures. Let me just get the right one. Just 1 second. I think it's this one. Yeah. So we created this test, and that's a bit of chaos monkey here, right? So what we do here, because the code is already in the main branch for the cluster, it's not yet it's not tagged as a release, and is not yet released as a Docker image. So, or the JDBC driver as well is not released, but the code is already in the main branch if you want to experiment with this. But this test, what basically does, it starts 2 servers, right? You see here in 2 different ports. After it starts, it waits a bit for them to start, right? And it starts this multi-node integration test. What that does is it keeps sending queries to the database, right? A lot of inserts, updates, deletes, etc., etc., etc. Then we kill one server, right? That's what happens there. And we check and wait to see if the connection is restored, because it's just 2 servers. Each should employ 10 connections each. So it should raise to 20 connections. It's 21 because the checker here is 1 connection. And sometimes we notice that 1 extra connection is kept by Hikari CP just because it doesn't kill connections too eagerly, right? If he has a connection, it keeps a little longer. But here we can see that 1 server was killed, and the other one took the load. You see, it increased its own pool to 20 because these are connections from the database perspective. So we are reading in the database how many connections are there. So we restart the server 1, right? And we check again for the connections, right? And they should remain at 20, right? Now with 2 servers. So it means that the server dropped 10 connections, and the server that came back created again its own 10 connections. Then we kill the other server. And we do the same, right? We restart it and check connections, and they should remain at the target 20, right? And that runs every time we commit anything to our source code, along with more than 800 tests. I think we are close to 1,000 tests running in our integrated continuous integration. So we're very confident about the code we are pushing there.
Okay, in this case, there's another question. So why not just scale the database together with the app? So why do we need a proxy? Why not just scale the database?
Very good question, and that would take another meeting of us, Catherine, to just go.
I'm all up for it.
I need to call out here a bit of a marketing stunt from the cloud providers in relation to these auto-scale databases, right, that they provide. It's not that easy to auto-scale a database, right? So I wrote an article for InfoQ in 2023. It's called Design Pattern Proposal for Auto-Scaling Stateful Systems. And if you read that article, you're going to understand the core problems of auto-scaling any stateful system, which is a database, right? It's a stateful system. Its job is to keep state, right? And the main problem when you're saying that you're going to auto-scale a database is moving the data, right? So if you need to put another node, you need to move all the data from the previous nodes, or at least the data from a certain shard if you're sharding the database. Modern approaches, you're going to be sharding the database in sections. If you want to add a node to a cluster, to a database cluster, you need to warm it up. And that means if the database is big, moving tons of data. So if you leave it to the last moment to do that, you're not fast enough to auto-scale, right? So what usually I believe the clouds are doing, from what I've learned so far, they keep a node pre-warm, right? So you are paying for that extra node in advance. So it's not that
Exactly.
magic, it
Yeah.
magically creates a node and magically the data is there. Like they need to pre-warm that node. So if you're paying for an auto-scale database, you're probably paying for 1 or 2 extra nodes already in the price. So when they say, we scale to another node, that node was there already, probably nearly in sync with the cluster. And then if you need a node, they finish syncing it and put it in the cluster. The article speaks more about that. You can see there, I did create an open proposal on how to solve most of these problems, because that's something I think is missing as well. Like, I think there is too much talk about like these auto-scaling databases. Nobody explains how they really work, how are they moving the data, when they are warming up these new nodes. And it creates the impression that is magic, right? But there is no magic, right? Like
Yeah, exactly.
there,
It's all
every
about the money. Yeah. So if you really, you're right. There's no magic. There's just this over provisioning, and you have to pay for that, right? So and then it just sums up all the bills that you have to pay, and then the cloud gets too expensive. So
Exactly.
yeah.
And that's another core principle in OJP. We wanted something that you can deploy in one cloud, and if you don't like that provider anymore, you migrate to another, right? And for us, it's very important that people understand how we do things, because explainability is something important in my view. Like, and
Yeah.
that's something I think it's missing in the cloud providers, and usually that means one of the two, for one of the two reasons, or that technology is so good that they don't want to share, or is so crappy that they're not brave enough to share how they are doing it.
Right. Exactly.
We don't
Yeah.
know, because if it's closed, right, like maybe it's a crappy way to do these auto-scaling things. We just don't know. And not knowing is something that I don't like. As an engineer, I like to know exactly how the plumbing is done. And that's what we try to do here at OJP. We try to be fully open how we do things, like why we do them in certain ways, and to give full confidence to whoever uses our product, that it will behave like we say it will, and you can check the code, right? The code is in GitHub.
Yeah. Yeah, so as far as I understand, so the OGP, and there's another question, which is the full form of OGP. So for everyone who just joined us, OGP is Open J Proxy. I posted the link to the GitHub of the project above in the chat. You can find it there. And so, as far as I understand, it is cloud agnostic and database agnostic, right?
Yeah.
And there is the question from the audience. So, what are the supported databases?
Good question. So in principle, it can support any database that delivers its services through a JDBC driver, right? Which is every relational database that exists, right? If you don't deliver a JDBC driver, you're not like one of the big database. But we do have integration tests with the major databases, and I can cite them. So it's Postgres, MySQL, MariaDB, CockroachDB, H2DB for tests, right? If you want to do integration with in-memory tests, is already embedded in the server. And then proprietary, we support, not that we support, but we do integration tests with Oracle, SQL Server, and IBM DB2. So these are the proprietary that we test for every release. And we have a bunch of tests. Like we deeply test a lot of things with each database. Like I said before, is around 1,000 tests in total. So it's a very large amount of testing that goes through. You can go through our integration tests in the test folder of our project. You can check there, like there are tests that apply to many databases. And the ones that are for Oracle, for instance, they are prefixed with Oracle. So you can check there what we are testing for Oracle, what we are testing for other databases, and you can contribute. If you feel like it's missing some test, just add it there, create a pull request, and we'll evaluate and add it in.
Well, that's nice. And speaking of tests and performance, so the title of our stream, right? The increasing the performance of your applications with OGP. So, what exactly are we increasing? What kind of performance indicator are we increasing? So, throughput, latency, memory footprint, and that is the first question. And the second, if you have any performance tests and results that compare the usage of Open J Proxy against the direct connection to the databases. If you could show that to us, it would be wonderful.
Yeah, I do. Let me share my screen again.
Uh-huh.
And there's 2 articles about that at the moment. We did 2 comparisons. It needs more, okay? So if someone feels like doing other types of testing, please do. We want people to hammer OJP. We're strong believers that it can take a good beating. So you can hammer it. Just try to break it and tell us if it breaks and if it doesn't, right? Because either way, we benefit from it. So
well, I'll definitely try doing that. I'm very, very good at breaking things. Exceptionally good. I should have been a tester, I think.
Lovely. So let me just find here. I never know in the page where I need to go to find the articles. I found them. It's posted, I believe. Yeah, because you see, it's a sub thing. It's not very intuitive. Okay, so I'll go through the first article first, and I'll explain what happened here. So what we did here is basically we deployed 2 DigitalOcean nodes, very small ones, 1 CPU only, one with Postgres, one with the OJP server. And then we fired this test against it. So we fired 6,700 queries with OJP and without it, right? And without any pool, just pure connections, just JDBC opening, closing connections, okay? So the duration of the test is 1 minute, the ramp up. So with OJP, it took 64 seconds to finish, and without OJP, 80 seconds. And that was the first surprise we took, right? Because we thought OJP would save the database resources like CPU. We were most concerned about CPU because we even looked at memory, but we didn't track because DigitalOcean also doesn't have good tools yet to track accurately the memory usage. So we didn't want to get false numbers as well. So we focused on these tests on CPU. So CPU was our focus. You can see that with OJP, the CPU max was 14.8, and without OJP was 61.1. Right?
Wow.
We see that shielding, right? That back pressure right here, right? And also, the average CPU dropped a lot, like 4 times scale. And the most surprise, no queries failed. That's 100 queries failed. That's because we did add in purpose 1 poison query, which has the division by 0, just to simulate 1 query that continuously failed. We also have an implementation of a circuit breaker. So we wanted to test that in conjunction with the pool. So if a query fails continuously, we stop sending that query to the database. So that's our circuit breaker. And then, it behaves like a circuit breaker. We try again later. If it works, then okay, that query can flow again to the database. But if not, we keep blocking.
So this way you don't put unnecessary pressure on the database, right?
Exactly, yeah. And think about it. Like when your database is about to go down, you start seeing timeouts, right? Repetitive timeouts. And you usually start seeing timeouts in the heaviest queries, right? Because they take longer. But if you don't have something like a circuit breaker to stop them from going to the database, it's just a snowball effect, right? Because your database is already under stress, and you're sending these big queries that they're gonna time out because the database is under stress, it's about to collapse. If you don't have something like OJP in front, it will collapse. So OJP is the very last resort to protect your database. And if it starts seeing a query failing continually, continuously, it will stop sending to the database, and that might very well mean a situation of a database going down or not going down and being able to recover over time. You're going to fail some transactions, some queries, but is that situation? It's better to lose a hand than to die, right? To have
Yeah.
the database. So it's really an extreme situation. So it does provide that extra. So you have your back pressure by limiting connections. You have also an extra protection of the circuit breaker. And the very surprising thing for us was the average query duration, and that was like mind blowing, because it's like 50% smaller than without OJP. And we need to remember that there is an extra round trip in the middle, right? You're putting
Yeah.
an extra server in the middle,
Mm-hmm.
and that was amazing. Like, so it was very encouraging. We didn't do further testing with this until we came to this questions. Please send questions if you have. But the
Yeah.
article is here under my name because we didn't
Mm-hmm.
have a page at the time, so I published under my name. Now we have a Open J Proxy in LinkedIn that concentrates all these articles, and we did push harder. So, like I said, we like trying to break it. So, if in that situation we just send 6,700 queries, in this situation which was 100 threads, right? So was this number here. In this scenario here, we started with one thread with, I think it's 67 or 68 queries. The same queries that we used before, 68 SQL statements. This test you can find in our source code. It's called mini stress test. If you look for mini stress test in our test, it runs with our RCI/CD, just with a smaller number of threads, because we have quotas, right, in DCI pipeline. So it's not a stress test there, but it runs every time we build the project as well. So you can go there and you can increase the number of threads and do this test yourself to check if the results are the same, right? But the main difference here is that we started with one thread. So that one thread, we will execute 68 statements and stop. 25 threads, that's 25 times 68. Then 50, 75, 100, which was the other article, right? The other article only tried 100. In this article, we went on to 125, 150, 75, and 200. We basically kept pushing until the database broke. That's what we did, right? And then we put OJP and see what happens, right? So if it breaks without OJP, let's see how it behaves with OJP. And then we got to these results here.
Can you make them a little bit larger, please?
Of course, yeah.
Uh-huh.
Thanks for reminding me of that.
Oh,
That's
thank
something
you.
I should polish myself. So these are the results, right? Like, so for one thread is 68 statements. The average duration of these statements was 118 milliseconds for OJP, with OJP, better saying, and no failures. That's very important, right? Because OJPs should not produce any extra failures, because we are putting a proxy, right? That there is translation of information going on. There is, orchestration going on. There is the circuit breaker going on. So we wanted to make sure that it's zero failures, right? That we didn't add any failures to the process. So you can see that it remains zero to the very end, to 200 connections. At 200 connections, 13,600 statements were executed. In the average, that's the most fantastic thing I think we showed here, because look at how stable the average times are with OJP. Like, it doesn't, like, you see this growth. This is substantial growth. It's 200 times growth, right? From 1 to 200. And it is only, let's remember, it's only one CPU for OJP and one CPU droplet for Postgres. So it's a very small setup.
And that is beautiful.
It is quite encouraging. Like I said, it's a specific test. We don't think this will be every scenario. There is no reason to believe that. But it's very interesting how it behaves under stress. And the most interesting thing for me was this with one thread. Because with one thread, I was expecting that it would be slower than with connections, right? With a normal connection. But it wasn't. It was actually faster. With plain connections was 201 milliseconds in average. With OJP was 118. and we can see that sometimes it's bigger here, and that's related to how the database warm up. We restarted the database every time. That's important to be said. So the database was, we completely delete all the tables, restart the database
Uh-huh.
for each of these lines. So every time we started a test, it's a fresh database. We see the database with thousands of records before we start the test. So the
Mm-hmm.
tables are not empty tables, they are with thousands of records. Because the test then becomes meaningful, right? It
Yeah,
reflects a
of
more
course.
real scenario. Now, without OJP, we can see that the times started to escalate quite
Wow.
fast.
Yeah.
At 125, the maximum here that it could tolerate, this one CPU Postgres, was 125 simultaneous threads, right? And
Mm-hmm.
after that, with 150, it starts breaking, right? You see here
Yeah,
that
and look how many failures. Oh, wow.
exactly,
Oh,
exactly. It starts timing out a lot of the times. It becomes super slow. You see more than 1 second
yeah.
in average.
Mm-hmm.
This is average, right? Those queries taking 10 seconds, 20 seconds, it really goes bad because, and also these queries that are failing, you don't stop them, right? They just keep flowing to the database.
Yeah.
So it
Mm-hmm.
gets really bad. So at 200, there was 408 failures, and the average time nearly 2 seconds per query, uh, which is
Yeah,
three
compared to
times.
OGP, I mean, 77 against almost 2 seconds and zero failures with OGP and more than 400 failures with pure plain JDBC. That is just absolutely fabulous. I mean, it's incredible.
It is,
That's
yeah.
yeah. Mhm.
Ponderating and doing the devil's advocate here, like it is an extreme comparison, right? Like in normal applications, we don't expect to see these extreme results, but we are testing for extreme results, right? We want to see like when things break, when they, you push to the limits, and what happens then, because that's what matters, right? Like everyone can create architectures that can take 10, 20 threads. That's if you're doing some small project, you don't need OJP, right?
Exactly. Exactly.
OJP is if you want something that can tolerate growth, right?
Yeah. Yeah,
And then
and yeah, sorry to interrupt you,
go ahead,
Rogerio.
yeah,
It's
please.
just
No.
that I've seen so many users and customers that had built the application and Java application, and everything was fine, but it was built for a very stable flow of requests, and it wasn't actually suitable from the start for traffic spikes. And
Mm.
when the traffic spikes come, for example, on Black Friday, right,
Oh yeah.
or whenever, when somebody blogs about the discounts that you offer on your website, whatever, right, then there's this
Hmm.
huge traffic spike, and many applications, really
Go
many
down.
applications are not ready for that. Yeah.
Yeah, they go down. I've seen it many times in many
Yeah.
different companies. Also, if you're under a DOS attack, right, is another scenario.
Oh
uh,
yeah.
which
Hmm.
is, which is the same situation, right? Someone is
Hmm.
pushing traffic to you. OJP will not prevent a DOS attack, but because it's a back pressure mechanism, it helps to defend your system, right? So it's one of the components that you should put in your puzzle to defend also against DOS attacks. So
Yeah.
increasing demand can be legit, increasing demand, like you said, a Black Friday, or
Hmm.
Neymar posted about your product, right? Or
Yeah.
Cristiano Ronaldo,
Yeah.
etc. And suddenly, or Giselle Bündchen, and suddenly you have that all that traffic. That's one scenario, but also can be a malicious attack, right? And you could be under attack of a DOS attack,
Yep.
and this would serve as a protection, an extra protection, right? One of the
Exactly. Exactly.
these are the main points, right? So up to 20 times faster than average query limits at 200 threads, right? At the very extreme, 100% in
Hmm.
failure prevention, and that's uh, across all the attempts we
Hmm.
did, right?
Yeah.
So
Yeah.
JDBC pure, the JDBC failed with OJP never failed, and
Hmm.
stable latency, we talked about that already, even under 200 concurrent threads. Uh, I think that's those are the tests we did so far. We want to do more. We want people to do more,
Hmm.
and we are eager to listen to those results. And bad or good, like we grow, we have a very open mentality here. If we find a failure, we make it stronger, right? And that's how we're gonna make this product, a cornerstone of the Java ecosystem, by finding all its small failures and fix them all. One of the things we fixed was that it didn't have a circuit breaker. In our first tests, we saw, okay, what if a poison query is there, or if you start timing out queries, what protects the database against that? We didn't have a circuit breaker. So we added because of empirical evidence, and that's what drives us here.
Yeah, and
At
that's the
OJP.
power of open source, right? So there's a huge community, and people test the solution, they try it out, and then they report bugs, offer suggestions, or contribute to the project, and then the project grows, right? So it's much more efficient than proprietary software that is developed somewhere in the in the heart of a major corporation. Yeah.
Exactly, yeah. And look, I worked in these big corporations, and there are good products, right? But there is also bad products sometimes, and you cannot distinguish, because sometimes, like I said, sometimes there is this idea we just throw hardware at it if we need, and sometimes you
Yeah.
don't see the issues because in the background they are throwing hardware or fixing up things. You cannot know. That's why open source is so cool. Like you said, you can see what's going on. You can help. You can put your fingerprint into it.
It's
And
transparent. Yes,
exactly.
exactly.
I don't know
Mhm.
if we have more time, Catherine. I'd like
Oh,
to talk
yeah.
about
So
this as well.
I have some more questions, and then there is the question from the audience. So, can
Okay.
OGP be compared with Oracle TAC feature?
Uh, Sorry,
And
I tried to stop presenting, but it didn't. So
yeah. So let me just Okay.
thanks.
Right.
So can you repeat the question, please?
Yeah. So can OGP be compared with Oracle TAC feature?
TAC feature.
Yeah.
What the TAC stands for, I don't remember. I remember Oracle UTC, UCP, and Oracle
Okay.
CNAM. CNAM is the proxy, right, for Oracle.
Oracle TC. Let's check. So if Hargavandana, I'm sorry if I'm pronouncing it not in in the good way. If you could specify what you mean by Oracle TAC,
Yeah,
otherwise let's.
I can tell that OJP is a competitor of Oracle CNAM, right? Oracle CNAM is the proxy, so we are a proxy. We are competitors with Oracle CNAM, so that's our competitor there. So OJP aims to replace other proxies. That's the field we
Application
are competing.
continuity or transparent application continuity. So I guess
I'm not familiar with
Oracle.
TAC at a deep level. I do know that Oracle has the Oracle UCP, Universal Connection Pool. I've been to a meeting at Oracle, and one of the engineers showed interest in implementing Oracle UCP inside OJP. So there was very good feedback from one of the engineers that sit that meeting. We didn't talk further yet, but there was an initial interest that's not formal yet, but there was an interest of potentially implementing Oracle UCP inside OJP server. So you could use HIC-RCP or Oracle UCP. What Oracle UCP do for Oracle is it does a lot of things like disaster recovery. It can understand if the database is under stress. So it has extra protocol with Oracle database. So it can fail over to a different server. So it gives a lot of extra functionality for Oracle database, right? But it's only for Oracle. So there is those conversations going on in the background. It's something we want to evaluate. We don't want to close OJP for any solution. So if Oracle has interest in putting their connection pool inside OJP server, we are open to that. We're going to help them to do that. And if other providers want to do the same, like SQL Server or DB2, we want to do that as well. Like we decided for HIC-RCP because it's a popular and trusted connection pool, but we are not bound to that. Like it's an architectural decision that we made especially based on the fact that it's the default connection pool for Spring Boot, which is the most used framework. I hope I answered the question there.
I guess yeah. So sounds very reasonable. So I have another question. Uh, Sorry, there's my dog somewhere in the background. So
He's interested in OJP. He's like, this is
yeah,
the project.
very very
This is
avid
cool.
listener. Yeah, he's always present in all my streams, but he's very shy, so he's somewhere under the table, but he's always listening. So let's say hi to Marcel. Right. Okay. So yeah, the question. My question is: a OGP shows like fabulous results when we really need to scale the application, and there are so many connections to the database flowing
Mhm.
in the usual times, when in the stable times, so to say, right, when there are just several connections to the database and we basically don't need the proxy. Do you switch OGP off, or do you let it run continuously with the app? And if it
Mhm.
adds additional latency, because that's just another a layer between the application and the database. So what?
Very good question.
Mhm.
Very good concern. Yeah, we thought it would. We thought it would add latency, but even at small loads, you remember from the test that with one thread of 68 queries, which is I think is a small app, right? Any small shop can do that. Like a few users, doing shop carting, you will have that 67 queries very easily. OJP with tens of queries, it becomes faster already than not using OJP. And that's related to one of the things we do in OJP. We don't allocate connections when you don't really need them. For example, the JDBC driver, first you need to get a connection, right? It's a very old specification, right? So the first thing you do, you get a connection.
Yeah.
I read some documentation that says that modern drivers don't actually give you the connection, but like for proprietary drivers, you would have to look into each source code and see if they really are not giving you the connection or if they are giving you a real connection. In OJP, we don't give you the connection right away. So what you get as a connection is a virtual connection, right? So until you prepare your parameters in your prepared statement, and or if Spring Boot is doing that for you, all the same, right? Because Spring Boot uses JDBC under the hood, Spring Data specifically. Uh, Up until the moment you reach to the execute query or execute update, only in that moment we allocate a connection. So we delay as much as possible the allocation of the connection. What that means, that connection can be doing other work, and that's the magic, right? Because it can while you are doing your parameters, it's very small, right? It's very small, it's nanoseconds, but we try to save those nanoseconds because nanoseconds at scale count.
Yeah.
And that's what you learn when you work in big projects. Every nanosecond, every milliseconds count a lot. So if you can save milliseconds,
Yes.
they count a lot. So we try to save those nanoseconds. We try to delay the allocation of the connection to the very moment where you need to do the update. And we try to speed up how we release that connection to the pool so it can be reused by other threads. Also, less connections. We talked about this already, right? If you have less connections, the database doesn't need to be switching between different contexts. So it gains on that performance. And we have this low query segregation that is something else we created. This nobody has, and is basically a bulkhead with a twist. And the twist is we measure every query again every time of every query, and we keep a ponderated average of every query, and we segregate them into two bands in the connection pool: this low query band and the fast query band. So if you have a lot of slow queries, they're not gonna clog your connection pool because we don't let it. They will be directed to their side of the connection pool. It starts with 80-20, so 80% of connections are for fast queries, 20 for slow queries, but you can change that if your system needs different scenario. You can change that. We also implemented a still work methodology on this, meaning that if the part of the pool that is dedicated to fast queries is a bit idle, is not using all its connections, or its slots, we call it slots, right? It's a slot for execution. It's basically a semaphore, right? That allows you or not to execute. If there is too many slow queries and there is a space in the part of the pool that's allocated for fast queries, it can borrow connections. So it can always try to do the very best usage of the resources. So all these things combined, to answer your question, allowed us to show in these tests that we are fast even in small loads, which we didn't think we would be. If you send one query, absolutely, you're going to be slow, like probably maybe even twice. We don't even test that. We
Mm-hmm.
never test one query. I don't
Mm-hmm.
see the purpose of testing one query.
Sorry.
He also doesn't see the purpose. Like,
Yeah, he totally agrees with you. Yeah, so that
yeah,
that,
no,
that was
no
his
purpose. One query.
indication. Yeah.
Who does one
So
query? Like,
who does one query? Really,
at least
that's
60, 100
insane.
queries. Like,
Yeah. Right. So, well, I'm sure that some of our viewers already want to try OGP out with their application. Is it already production ready?
uh, almost production ready. What is missing? Is missing more people trying out and bringing feedback. And that's the only thing really we need. We need to deploy the version 030, which will be the high availability version.
Mm-hmm.
And that's enterprise level, right? Like if you
Mm-hmm.
think about open source, that's something different about us as well. Like we are not holding off functionality to sell it later. Usually what a lot of open source products do, they give you for free the single node version, right? And then the high availability with cluster is paid, or there is some trick there, enterprise tax, or we're gonna release it for free in version 030 beta. Why do we call it beta? We just want to hear more from the community and build a trust, that the people are using it, and that there is no major bugs reported, right? That's what we
Mm-hmm.
are missing. I would say that the version we have, the version that we're going to release 030, it is production ready, even though it's named beta, for non-critical applications. Like if you're building an application for a stock market, or for a heart surgeon, don't use it yet. Wait a little bit more. But if you're building an application like a startup, or an application for your school, or something that you go, or more experimental applications, please do use, because that it's ready for production. It's going to be ready in version 030 with all these tests we talked about, and it's very robust. You can trust that it is very robust. And we're just waiting for this feedback, right? Like, oh, I'm using it. I'm like, if there is any sharp edge that we need to polish, that's the only thing we're waiting for in relation to launching a 100 production ready
Mm-hmm.
version.
Mm-hmm.
So it can be used in production just for non-critical applications. That's what I would say.
Well, friends, in this case, I encourage you to try OGP out like immediately after this stream. Just go ahead.
After this,
Yeah, at the weekend, this is going to be a weekend task, friends, to try out OGP and check it out with your application and see if it works, what kind of performance boost you get, if there are any failures, and well, file them, of course. Where can we file issues or proposals? By the way, it's a good
yeah,
question.
usually we start a discussion in our Discord group,
Uh-huh.
but you can also create an issue, no problem. Like
Can
we're
you
gonna read.
give the link to the Discord? So
Yeah,
yeah.
absolutely, yeah. And
Mm-hmm.
there is a button in our GitHub page as well, but I'll give the link here to make it
Yeah.
easier.
Mm-hmm.
So at
Right.
the very top of our
Mm-hmm.
apologies, I cannot do two things at the same time. Just copying the link.
That's okay. Yeah, just
Uh,
yeah, pass it to our chat and I'll
yeah,
forward
this
them
is
to.
the Discord invite. It's
Mm-hmm.
also in the front page of our GitHub page,
Mm-hmm.
so
Okay.
you can find the button there. We have
Mm-hmm.
a page on LinkedIn that's our main source of communication in relation to publishing articles. I've been publishing articles also in Java Pro. Usually, I
Mm-hmm.
publish the release articles in Java Pro, and I'll
Uh-huh.
be. We just got approved to publish an article in Java Pro printed edition. So the next Java Pro printed edition
Oh,
will be
that's
talking about
nice.
OJP.
That's
Yeah.
nice. I have already also filed the proposal for the printed edition of Java Pro, so fingers crossed. I'm also
Well,
going to be there. We're going to be in the
yeah.
same edition, maybe. Fingers crossed.
Well, hopefully, yeah.
Right.
Hopefully that.
Yeah. Yeah.
So yeah, so these are the channels. Like if you want to file an issue directly, maybe we take longer because we usually engage with people in the Discord. Like you can start a discussion, say like, oh, it didn't work for me, this thing, and then people will come like, oh, you can try this, that, and if that may produce an issue or an update on documentation, right? Because we had, for instance, issues on people running the project locally because of some configuration, some parameter they need to pass extra, like in some setups, and we added to the documentation. So you can see there, in that document that I was showing for Spring Boot, there is one issue there that happened to one of our users that is already documented there. So if you get that issue, is already there for troubleshooting, so you can just apply the same solution. But that's just
Mhm.
for running locally in IntelliJ or your IDE. It's not an issue on running OJP itself.
Okay, I see. So, friends, I think we are going to wrap up in like in a couple of minutes. If you have any more questions, please, that's the time to pass to ask them. And meanwhile, we have the follow up on the Oracle TAC from our viewer. So, TAC, transparent application continuity, enables application sessions and even ongoing transactions to fail over seamlessly in the event of a recoverable outage, such as a node failure in a RAC EVN. So, does OGP do the same thing?
Not yet,
Mhm.
but this is in our list of things that are proposed to be done. It will be evaluated in at some point, because you
Mhm.
see there is a decision to be made there. Like
Mhm.
either we implement that all ourselves, or we integrate things like the Oracle UCP, right? Because Oracle UCP does all of that already. So
Mhm.
should we implement that, or should we onboard connection pools of the providers that does that for us? And the decision might be one or another or a mix, because probably for open source there isn't a single tool that does that, right? Maybe there is many. We didn't do that research, so there is a bit of research to be done there to make a decision on how to do that. So currently OJP will not fail over automatically. We are thinking about how can we do that. If you have ideas, it seems that one of the listeners knows exactly how Oracle does that. I think if you bring that knowledge into the project, that would be great, because it's a starting point for us to start thinking about it. So it is in the
Mhm.
roadmap, but there is no dates yet on when we plan to implement it.
Mhm. Okay, so I have two more questions. So, one question is: are you planning to provide commercial support to enterprises that are going to use OGP?
Yes, yes,
Mhm.
we
Mhm.
plan to create an organization. We are still thinking if it's a non-profit or for-profit organization. There is some questions related to that. Is not yet in the plans for the immediate future. The immediate future is to release the version 030, so we are focused on that. But next year we wanna be doing things related to structuring like the company and the support, paid support. That's how we see funding the project in the future, right? With paid support.
Yeah.
We don't
Mhm.
plan to make licenses of anything. The
Mhm.
project intends to be fully open source, fully free forever. And I'm saying it online here live to make sure that that gets recorded and I get asked later
It
if that
is. Yeah, it's going to be carved in stone, or well, in a video.
we do plan
Like,
to
like so.
fund the project with trainings, support, and paid support, like you said. That's the intention. Um, but besides that, if you want to use the project, the intention is that it's always free, always open source.
And
That's
that
the
is,
difference we are bringing to the
and that
market.
is only fair. I mean, open source projects have to exist, right? That's very important. But the engineers working on the project also would like to have some for their work, some
We do have a
right.
buy me a coffee button. If you want to leave a coffee
Yeah,
there, we got a few already, so
yeah.
it does help. It does help paying for cloud hours. There is always things. Sometimes we give T-shirts to some members of the community, so there
Hmm.
is costs involved. already, and we do use this money for that. So
Yeah.
that's the current funding. That not
Mhm.
much really, but in future we're going to be opening the company. We're going to be structuring. We're going to be looking for funding from companies, from open source institutions as well,
Mhm.
and we're going to be selling paid support because
Mhm.
that's important for corporate users,
Yes.
and I
Mhm.
think Java is used a lot in corporate,
Oh
right? So
yes,
that's
exactly. SLA is very important. Yeah. So for
yeah.
enterprise Java applications. Yeah. So, um, and the last question, I guess. Uh, oh, we have a comment. Congratulations for the presentation, Rogerio,
Thank you,
and
thank you.
CyberJar for the opportunity. Thank you. Right, it is really nice. It was absolutely fabulous talking to you. Very interesting. I'll make sure to try OGP out, and I encourage everybody who's watching us to do that. Where Rogerio can viewers ask you questions. So where do you dwell, in which social networks, or maybe offline events that you're going to visit? So where can they find you?
So we started advertising OJP 3 months ago. So we reached now like more than 150 between stars, forks, and watches in GitHub, which is a major achievement because I was comparing this with other proxies. We are much faster to reach those numbers than other proxies. So where I will be, not in many places. I'll be mostly online, and that's
Mhm.
due to a very good reason. I have small children at home, so traveling is not easy at the moment, but it's the best moment of my life as a father. So that it's a very good reason. But I did send papers for some conferences, specifically the JCon I already submitted, the Java one I submitted, but I'll see if I can go, if even if they approve, because I think the Java one is harder to get in. The
Yeah.
JCon, it can happen. Like I said, you said yourself, you applied for the printed edition. I got confirmation for the printed edition, and I got contact of one of the editors that also decides for the conferences, right? Like he said he
Yeah.
would be giving his support, but there is other people involved, right? So it's a
Yeah. Of
committee.
course. Course. Yeah. I
So
also applied for JCon conference,
mm,
so hopefully, like
hopefully, most of
we're
us,
going
yeah.
to
So
meet there.
hopefully, JCon
Yeah.
conference, that's the one I applied. But what I'm trying to do is mostly these online conversations. I've been to 4 or 5 Java user groups now in online talks. One in
Mhm.
person here in Dublin, which is my city, right? So that one was in person. But the other ones are online. I have one more scheduled. There was one yesterday with a Java user group in Brazil. There is one now. There's 2 more scheduled for December, which is next week, right? I don't
Mhm.
remember the dates exactly. It's one in the beginning of the month, one in the end. One is for Riyadh in Saudi Arabia, and one is for a
Cool.
United States Java user group. Yeah. So we are reaching different Java user groups, offering this talk, and yeah, people are joining in, mostly Discord. About the networks, I use the Discord a lot because I like the interaction with the community. I like to meet
Mhm.
people. I like to talk to them. I like to listen what are their pain points, and I think Discord is a good tool for that. I also started
Mhm.
using X more actively now for the project. We have this page on LinkedIn, the Open J Proxy page, uh, and we just started a Reddit page, which is just have
Mm.
one post there at the moment, but we got one volunteer in our community to start, building up the Reddit presence. So that should be coming up soon as well.
Cool. Cool. Well, thank you so much, Rogerio, for this talk. Thank you, our dear viewers, for joining us today. It's really exciting, and OGP, I think, is a very very promising solution. And I wish you all the best, Rogerio, with the project. And I'm certain it will succeed.
I'm
Right.
also certain, and I want to say why I'm also certain, because people like you are very kind to give us the space to speak about it, to take the time to look into the project. I think this spirit, the open source spirit, is something that I felt in love with. It's
Yeah.
amazing how people come together, how people help each other. how amazing people you meet in this journey. So if you never worked in open source projects, OJP is a very nice opportunity, because we are in the beginning. Like, it's not like Tomcat or Apache or some Apache commons that are there for years, and it's hard to get into the communities. Our community is very young. We are building principles of inclusion. There is no wrong ideas, there is no stupid ideas. We talk freely, we try to figure out things together, and people are joining, and I can say only good things about our community. And Catherine, thanks again. Really appreciate our talk. I think the questions were amazing. You really did your homework, you prepared well. Like anything else in the channel, I was telling Catherine before, this is a channel that I was hoping to see in the Java ecosystem. I think the quality they deliver here at CyberJar is fantastic, like unmatched. And I'm sure that we will only grow as well as a channel for
Thank
Java
you.
technology.
Thank you, Rogerio. Yeah, so I'm doing my best, and I'm really happy that people like you appreciate that. And we have many subscribers, and I really love that I can be useful to the community, because I love it also very much. I love the Java community. I love the open source community. It's very heart warming feeling, that when we are all together, there is no hostility, there's no aggression, right? And we all share expertise, knowledge with each other. That's just absolutely beautiful. I love it too. Yeah.
Absolutely.
Yeah. Could you please send the link to the OGP LinkedIn page so that I can post it in the chat?
Absolutely. Let me find it here.
Yeah. And I will also post the link to the GitHub page of OJP and LinkedIn in the description of the video later on. So, and the recording will be available. So if
Perfect.
anyone has joined us just recently, wants to watch the full talk, then the recording will be on YouTube and on Twitter. I still call it Twitter. For me, it's
Yeah, I
always
cannot
Twitter.
call it X. X is a bad name.
No,
Like,
X is very weird.
it is
Twitter,
weird. Yeah, I know.
yeah, yeah. So, but anyway, the recording is going to be there, so you can rewatch it. And yeah, thank you again, Rogerio. Thank you, my beautiful friends, my good friends, and have a nice weekend, everybody.
See you guys. Thank you.
Bye bye. Bye,
Bye bye.
everyone.